Hello and welcome to this Sophistic tutorial. In this video, I will show you how to create a parametric superstructure family in Revit to optimize your workflow with the Sophistic Bridge and Infrastructure Modeler. Superstructure families are created in a two-dimensional plane of an adaptive family. They are placed in an interval along the axis alignment to be swept with a perfect accuracy. We can use this additionally to parameterize or to vary certain aspects of the superstructure along the axis alignment. The family I will create is a superstructure family as you see it here. I recommend taking a quick screenshot to see all the parameters that we will use to control the geometry of the superstructure along the axis. The parameters that we will create are on the one hand directly user accessible. What do I mean with that? When we take a look at the family type, I mean the parameters that don't have a formula attached to them. And we can use them in the superstructure interface directly. And you can see them here as they are transferred directly as an input to the superstructure command in the Sophistic Bridge and Infrastructure Modeler. The second type of parameters that we will use are the ones running in the background. When we take a look at the family type once more, I mean the ones that are controlled by the formulas, and those will not be directly accessible through the Sophistic Bridge and Infrastructure interface. Let's now create the Revit family. In Revit, I start by creating a new Revit family with the metric generic model adaptive template. In here, I turn my reference plane from left to right, again, because this is the plane in which we will be working in. And I will create one reference point, align it to the middle of my family, and swap it to adaptive. You can see it over here as well. The first parameter that I want to create via properties types, and first step, create a new type for the family, type number 1. Create a new parameter down here of an instance parameter, which will be the width of the deck. It's a length parameter and grouped in dimensions. We can also already assign a width to this parameter, which will be 14,000 millimeters. When I now start by creating and setting a work plane to create my reference point, in my adaptive point, I can select it and move it orthogonally to the plane it was created in. You can see that the offset changes. You instantly notice if this is the reference of our axis, we now want half the width of the deck to be assigned to this point. So we come back to the family types, create a new parameter, which I will actually duplicate from this parameter because I then don't have to copy the settings, where I set half in front of the name of the width of the deck. I then copy the name of the width of the deck, and adding a divide by 2, I automatically assign the value to this parameter. This parameter will now not be accessible in the superstructure interface, but the width of the deck will be. For me to have a little bit of a cleaner separation of the two, I like to edit this parameter now and change it to be grouped under Other. This doesn't have a direct effect, but it makes it easier to handle in the family. Click on OK. I can now select this reference point and assign the offset with half width deck. When we take a look at the family we want to create, you can see that a slope is also assigned to the width of the deck. And to assign this, I create a new parameter, which will be my slope of the deck, an instance parameter, and this one will now not be a length, but it will be a slope. I click on OK, and the slope is immediately assigned. I assign a value to it, and what I can do now is I can create another parameter for the height of a second point in reference to the width of the deck. I will call this parameter height top left. Instance parameter will be a length and it will be controlled by a formula, so I set it to other. Here I can now select the half width of the deck. This will be the one value that I want to assign here, as well as multiplying it with the slope. Now you can see that the length times the slope gives me the height parameter. I can now assign the horizontal plane of this point, create another reference point within this plane, and assign the height top left parameter to this point. This way I now already get a proper slope. Let's actually double check. We can select the points, create this reference line, select the right plane, and in here I can now check for the angle between these 2 points. I also need a line. I can now check the angle in between, and you can see the parameter is assigned properly. Let's dissolve these lines and keep going with the other points. Because next up, I don't want to use the offsets as a parametrization method. This time I want to use the dimension lines as a parameter. To do so, I create a point in this plane of my other point. I assign it, or I align it to the vertical proper assignment, and I create dimension line in between the two. I can now check for the parameter that I can assign to this dimension line, and I assign the width of the deck to it. You can immediately see with the right order, the width of the deck will be immediately assigned to the proper reference point. This dimension line will be visible in the Sophistic application for the superstructure. Okay, let's create some more parameters, because as for the input, we also want to have a parameter for the width of the web, which is an instance parameter of the type length. We also want to have height of the web. You can also use the duplicate function and just change the names accordingly. Height web. We need another parameter for the height of the cantilever. We need a parameter for the cantilever itself. And we need another slope parameter, so I will actually copy the slope for the slope of the cantilever. You can sort your parameters very easily by clicking the sorting functionalities down here, and I like to have it sorted with the width first, then the height parameters, then the cantilever offset, the slope, and the slope of the cantilever. I will also assign a couple of values to them. And those will be the input parameters that will be accessible directly in the Sophistic Bridge and Infrastructure modular. Let's continue by creating the rest of our top structure for this family. I want to create 2 more parameters for the height of the top geometry, especially for the top on the right side, as well as the height for our cantilever drainage. How do we now get the height of the top drainage? We can use the width of the deck, especially the half width of the deck, which we can duplicate to create a negative version of it. I like to add a neg in front of the parameter, so negative half width deck, where I simply take the parameter and set a minus in front of it. And we can use this parameter to assign it instead of the half width of the deck times the slope. But as you can see in our drawing here, the slope is only assigned until the drainage, and then we have a positive slope. How would we handle this? We can just continue from the part of our drainage. So first we start with the height of the top drainage, where I now want to assign the negative half width of the deck and add the cantilever length to it before multiplying it with the slope, which now gives me the proper height here. Next up, from this height, we now want to go a little bit further up, so we can just copy paste this here, and we want to assign the top or the height of the top drainage plus the cantilever parameter. By the way, be careful to exit the already existing values when you add an plus to it. Program doesn't enjoy that. We take the length of the cantilever, multiply it with the slope. Okay, now we are ready to assign it to our points, but you can see that we do not have the offset to our cantilever yet, which we can assign to this vertical plane of this point by selecting it, creating a new point. And as the offset is coming from the right to the left, we do not need to take a negative value for the cantilever. And here we now have our horizontal indicators. All we need to do is create 2 more points in the horizontal plane. Do this for both reference points for the top already. Can select them now, and I can now assign the height of my drainage as well as the height on the top right. The only thing left to do here on the top is now to assign the thickness of the cantilever, which I called the height of the cantilever, which is reference to the most further out point here, as well as to the left one. I select both of them to assign the vertical offset, which is the height of the cantilever. You can see it moves to the top, which is the wrong direction. Why does it happen? Because the coordinate system of this reference point in Z direction looks to the top, which means that we need a new parameter for the height of the cantilever, which is negative. I change it to other, simply to have it more clear what it does, and the height of the cantilever should be assigned as a negative value here. I can select my points and change the assigned parameter from height cantilever. By the way, you can search up here for negative values, for example, negative height cantilever. Click on OK, and those are now my reference points. The next step that I want to take is to assign the height of the web, where you can see we once more need a negative value. So I come into here, height of the web, I copy this one and create a negative version of it. Height web, and I set a minus in front of it, and then it's assigned as an automatic parameter. Change it to other, and we are good to go. I set my horizontal plane of my adaptive point, create a new reference point in it, select it and assign once more the negative height of the web. All we need to do is now to assign the half width of the web as well as the negative width of the web. So once more, we need two more parameters to parameterize it via reference points. I will start with the half width web and copy this one for the negative half width web. I want this parameter to be divided by 2 for this one. And I can also select the half width web parameter, set a minus in front of it for it to be parameterized perfectly. Change it to other, simply for it to be cleaner. I now go to this reference point, assign the horizontal offset for 2 points that I can create in here. On the one hand, I want to assign half width web as well as negative half width web. You remember that the same slope for the top part of my superstructure is used for the bottom part of my superstructure, meaning that we can take once more these two lengths, multiply them with the slope that we assign as an input, and we immediately get the height parameter accordingly. So the easiest way that I like to do it is I copy my already defined slope or height parameters here, and I change it from height top left to height bottom left. And I take this one, copy it, height bottom right. All I need to do is now exchange the half width deck parameter with the half width web parameters. Once for the negative, which is going to be on the right. And as I can just get rid of the negative, I have both my parameters assigned very quickly. Let's click on OK. And at this point, we are done with creating our horizontal and vertical reference points. And we will use the last part of the parameterization. Let's have our height bottom left, height bottom right. All right, so these 2 points will be my references for the geometry. And what I want to do, and to clearly show it, I will activate the reference planes because I want to now use reference lines to create the intersection of a 60-degree angle here. Because this is usually a task which would require a lot of calculation via formulas to get the proper horizontal and vertical reference points. We can use reference lines to quickly get them to calculate on their own. I also select the bottom references of my superstructure on the top. Remember, they are parameterized with the parameter negative height cantilever, so the bottom of the cantilever. What I want to do is in this plane, I want the program to automatically rotate an offset reference line. How do we easily do that? We set the reference plane to this vertical plane of this point. We create a new point in it. And what I want to do is I want to assign a rotation angle. Let me quickly show what happens when I turn on this reference plane and assign a value to it. You can immediately see that in reference to the original point, it gets the rotation assigned to it. we can now use the vertical plane of this rotated point to create a point with an offset and use it as a reference line. I will do this for all the points that I selected here. So we want this one to rotate, we want down here another point to rotate, as well as over here. By the way, if you don't click on escape after using this command, you should be able to quickly set new planes to create new reference points. And now I want to select all of them by clicking once on tab. You can see that no parameters are assigned. And you can select them easily. The bottom points should have a fixed 60-degree angle. So I select both of them and I assign a rotation angle of 60 to both. And I turn on their reference planes. So you can immediately see that this one to the right turned not as according as I wanted to. This one is perfect. So what you can do with this one to the right, you can assign a rotation angle of 120 and it will rotate into the direction I actually want it to. Select the original reference planes to turn them off, and we can now see the proper planes and easily select them. What I want you to do is select the original horizontal plane of this point to create a new point in it. And what we can do is we can either just offset it by drag and dropping it on the right plane, or we can assign an offset parameter to it. And as we have the height of our web as a positive value, which goes up, already defined, we use the negative one for this point, you remember, we can use it to always have a long enough offset for this point. I do the same thing for the left side. Click on OK. Assign the height of the web to it. And by selecting this point and the origin point, I can create a reference line. I do the same thing for the points to the right. I select my model lines and change them to reference lines with not a reference. Now to the next part. The offset from these 2 points over here, by the way, here I still have to turn the planes off and select the new point. Turn this one on. I want to use the slope of the cantilever as a rotation. I select the point, and when I want to select a parameter in here, you can see that it is not possible to select a slope as a rotation angle of this parameter. But what you can do is you can create a new parameter which translates the slope into a rotation. To do so, create a new parameter, which I will call rotation, an instance parameter of the type rotation angle. Click on OK. All you need to do is to copy the name of the parameter once more and use it in the new formula where you calculate the arcus tangens of the slope, which will translate the slope into the rotation angle. I copy it because we want it to rotate once like that on the left side and once to the other direction on the right side. So we also need a negative rotation, which is simply the negative version of this parameter. Click on OK, select the 2 points, or select the left point first, assign the rotation angle to it. You can see this is perfect, rotated a little bit to the right. This one should rotate to the left. Now we simply select the vertical plane of these points to create 2 more reference points. Do this for the left side as well as for the right side as well as for the left side. select the point by clicking tab, creating an offset, and here I want to use the negative half width of the deck. You can see the offset here. I select the 2 points, create the reference line by assigning it is a reference line. Keep in mind, reference lines do not create geometry in the program later. I select this other point, which is assigned to half width of the deck. I selected these values simply for them to not create too much of an offset. Create a reference line, not a reference. And we are almost done, because as you can see here, this is actually the intersection of these two lines, the point that we wanted to create originally for our geometry, which would be a very hard calculation considering all the parameters we assigned to it. But Revit as a program gives us a very simple solution, which is to create a new point element on these reference lines. I do it once on the left here, once on the right here, and I can select this point. You can see that it's basically controlled by certain parameterizations along this reference line, because it's not created in a reference plane, which allows us to also host this point by intersection. Meaning that I can click this point, it's already hosted by this line, but the intersection with this line can be the new host. I do it also with the left side, and the intersection is found instantly. At this point, it might get a little hard to select the right point, so I want to clean up temporarily. I select, for example, these reference lines, and down here you can temporarily hide elements. I do this for a couple of my points. For example, the horizontal point here and here and here doesn't really interest me. Be careful not to hide too much. Hide them. Now I have these points here that I don't need for now. I can also hide this one so I don't accidentally make a mistake by creating my geometry. Do the same thing over here. This point I don't need, it would just get in the way. Now I can select the points and create new reference lines or new model lines. These model lines will then be used as the geometry for my superstructure command. Be careful not to select too many points. You can only select 2 points and click on spline through points for the program to properly recognize the intersections. Meaning, for example, here I have 3 points in one point. Make sure to only select one of them by left clicking. So here is my low point for the drainage, and you can see it all comes together now. Select these 2 points, and lastly I connect it all together. Now I have one boundary that can be controlled via all the parameters we assigned in family types. By the way, the program tells me to save this family. Let's do that quickly. Make sure to give it a proper name, for example, superstructure 1, and I save it on my desktop. Alright, let's play around with the parameters a little. You can see here that the slope is assigned to 2 degrees for now. I change it to 3. Click on apply and let's see what's happening. The program immediately updates the geometry. Can also move it back to 2. Let's make this window a little smaller. Which means the parameterization can be fully checked directly in the family. If everything's working, you can see here the intersection was found immediately by the program without further input. Let's click on OK and create it in a project. By the way, you can also reset the temporary height, and you can see here much more information available now. It's simply easier to create the intersection if you clean it up a little bit beforehand. Let's create a new project. I use the standard construction template. I go to a 3D view, go to Sophistic Bridge, create a new axis, click on OK. And by loading the family into the project, it is instantly available for the Sophistic Superstructure command. So here it is, you can see superstructure number 1, type 1, and all my parameters are available. So let's click on OK and just create it from start to end of this axis. No parametrization was done for now, but this can change quickly simply by going to the axis and creating a variable. For example, I create a variable for the height along the stationing, which should start at 4,000, should go up to 5,000, come back to 4,000 and go up to 5,500. Click on OK. And we can assign this parameter instantly to the height web parameter, or let's actually assign it to the width of the web. We don't necessarily need to assign the values accordingly. 4 meters might be a little much for the height here. And we can see down here that the assigned parametrization is added instantly to the width. The intersections are automatically found. And next up, I want to assign a slope parameter. Go to variables and call it slope, which is now not a unit type length, but a slope. And I want to go from 2 to 4 to 2 to 4. Click on OK. And we can assign this parameter once more to the slope parameter that we have in our family. Click on OK. And the parametrization can continue by every step that we take with this tool. You can see that it's slightly updated, and just for you to have an idea what's going on under the hood, you can double click onto the family and can see the amount of intersections that was created by the program to create this volume.